Alright, so this is number 2 of quiz 9.4 through 9.5. What we have here is a series from n equals 2 to infinity, and we're told to find out how it, if it diverges or converges. So this is the series, as you can see. We use the alternate series, the Leibniz test, or the alternate series test, alternating series, whatever it's called. And u of n will be this part right here. I'll circle that actually. Like that. And is it greater than 0? Yes, it is. It's a decreasing function, so the first term is going to be greater than the next term. And the limit as it approaches infinity should be 0. And the limit's right there. This behaves like n equals n squared over n cubed. As it approaches infinity, this should be a plus 2. These won't matter, so it becomes n squared over n cubed, and that's just 1 over n, which is 0. So it converges by the alternate series test. All right, on to number 3. Oops. There we go. All right, so we have n equals 2 to infinity of negative 1 over natural log of n to the nth power. We can put this in this form. We can take the negative 1 to the n out, and we have this now. And then we can do some more algebra crap with it, and becomes 1 over n to the ln n. That's the natural log power, rules of power, or whatever it's called. And we use the alternate series test again. These 3 check out. Some stuff over there. Gotta get rid of that. Alright, so here's the limit. We can just separate these two right here, because we're taking the limit of u of n as it approaches infinity. This becomes a limit as n approaches infinity of 1 over n times the limit of n approaches infinity of 1 over natural log of n, which is both just 0 times 0, which is 0, so it converges by the alternate series test. All right, on to number 4. Guess I'll start here. All right, so the series from n equals 0 to infinity of 3 to the n over 4 to the n times x minus 5 to the n. We use the ratio test for this. It gets a bit messy, I guess, somewhat. And we just calculate that out. 3 to the n times 3 times the absolute value of x minus 5 to the n times x minus 5. That's going to be the x to the n plus 1. And the plus 1 is just times the function itself. So it's that right there. And then we have 4 over 4n times 4, 4n plus 1. And we flip the other fraction because it's a to the n over b to the n. We have 4 to the n, 3 to the over 3 to the n times this absolute value of x minus 5 to the n. 3 to the n cancels, so does x minus 5 to the n, so does 4 to the n, and we're left with this right here. 3 over 4 times the absolute value of x minus 5, and that is your L value. Now, if you recall, when you do the ratio test, L is less than 1, or the absolute value of L is less than 1. So we have that right here. 3 over 4 times x minus 5, the absolute value of x minus 5 is less than 1. And to find out what L is, we just multiply with the reciprocal, and we get L is less than 4/3. All right, that shouldn't be too bad. Number 5. This one's a little bit tricky, I guess. So we have the series from n equals 0 to infinity of x cubed minus 2 over to the 2n power over 4 to the n. We use the ratio test for this, and we get absolute value of x cubed minus 2 to the 2 to the n power times the absolute value of x cubed minus 2 to the second power. Now, I forgot to add this in here, but this becomes x. Sorry, I'm left-handed, so you can't really see it that well, but because it's n plus 1, right? And that is just 2n plus 2. So, yeah. And it's time to reciprocal. These cancel. You're left with x cubed minus 2, the absolute value of x cubed minus 2 squared over 4 is less than 1. This is your L. And we just do that, multiply 4 to both sides, and we get that it's less than 2. All right, and starting from here, I guess, is number 6 of the quiz. It's split into 2 parts, I guess, because each one is asking for different things, but I don't remember which one exactly, but yeah. So it's this stuff right here. You just calculate it out. You have your L now, and then you have to find the interval and convergence, or the interval. So absolute value of x cubed minus 2 is less than 2, becomes negative 2. There's 2 right there. Add 2 to both sides, you get 0 and 4. Take the cube root. 0, cube root of 0, 0. Cube root of 4 is cube root of 4. That was redundant. But okay. And then the next part, number 6, I kind of messed up over here because I was looking at a different problem. But we have to check the endpoints now. So at x equals 0, the series becomes negative 2 to the 2 to the n over 4 to the n. Now, if you remember your rules with exponents, you can kind of do this algebra crap right here. And you know that a to the n times b equals a to the n times b. So by using that rule, you can kind of know that this is that. That's 2 times the n. N is the common exponent here, so we can just take that out and write negative 2 to the second power to the nth, or over 4 to the nth. And this just becomes 4 over 4 to the nth, which is just 1 over 1 to the nth. And this diverges. It doesn't really approach any sum as well. It just approaches infinity, I guess, which is another reason why it diverges. But it's also a geometric series since the common ratio is 1, right? And the ratio has to be less than 1 for it to converge. So since it's great, it is 1, so it's not less than 1. It diverges. And then we put in the other endpoint. At x equals cube root of 4. And you get the 4, it just becomes a 4 because it's x cubed minus 2. So it's a 4 minus 2 to the 2 to the n. And this again becomes 2 times 2 to the n over 4 to the n. Do the algebra stuff. You get 1 over n, and that diverges. So your final answer would be 0 is less than x, or x is greater than, or x is between 0 and cube root of 4. And this will be your interval, basically. They're open intervals. This is how it's going to look on the answer choice, I guess. All right, so it's not too bad either. Pretty simple. I guess that's it.